Welcome to Study Loop.
This is the answer to Chapter 21, problem number 90 from the Smith Organic Chemistry textbook. And this problem asks us several different questions. So it talks about maltose. So first for A, we're asked to label the acetal and hemiacetal carbons. So the acetal carbon is this one right here, acetal. And in green down here, it's not pointing to a carbon. This is the hemiacetal carbon. Okay, yeah, so that's A. Just remember acetal is connected to two ether oxygens. Hemiacetal is connected to one ether and one alcohol. So then for B, we are asked to perform a series of reactions. So for the first one, for B1, we're asked treatment with H3O plus. So that's going to hydrolyze the linkage between these two rings. And so what we will end up with is this. And this, the squiggle means that it means either or. So this alcohol could be equatorial or axial. And so it'll be a mixture, really, of equatorial and axial there. So then for part 2 of B, we are asked to use methanol and HCl. Methanol and HCl. And so just bear with me while I draw this. So this is not going to affect this top ring at all. So OH, 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 OH. Right. So the top ring really isn't affected at all. Really, the bottom ring is not affected very much. The only thing that's going to change is that hemiacetal is actually going to become a full acetal. It's going to replace the alcohol with a methoxide. That doesn't look good at all. So, right. So there will be a methoxide here. And again, it can be axial or equatorial. OCH3. Right. Okay. And then if for part 3 of B, if instead of methanol and HCl, we use lots of sodium hydride, so excess sodium hydride, and then excess methyl iodine. What we're going to do in that instance is make the methoxides of every single available alcohol in this molecule. So that's unfortunately going to look like this. Again, bear with me while I draw these rings. Okay, so there's our ring system. And now every single position that was a hydroxy group is now going to be an OCH3. So every single one of them. And however, what is going to be a little different is the hydroxy group that was part of the hemiacetal that is now also a methoxide. This time, its stereochemistry is going to be defined. So for parts 1 and 2 of B here, it could be up or down. But in this case, it's going to be just the equatorial because it starts from equatorial, and the mechanism here is not the same as treating with acid and the carbocation forming and then methanol attacking that carbocation. This time, we're actually pulling the hydrogen off and replacing it with a methyl group. And then so for C, we're asked to treat part 3 of B with, what is it? With aqueous acid. And so if we do that, we're going to split the 2 rings that we made in part 3 of B. And so the result of that will be this. So let me. Okay, so the result of that will be this. So we'll get that from the top half or the left half of the molecule above it. And again, the hydroxy group here that comes from cleavage of the ether linkage between these 2 rings that can be in either position. And then we'll also see. Oof. All right. Okay. And then so this other piece comes from the bottom ring or the right ring in the molecule from part 3 of B. So this guy is just going to be an OH, right? Because that's the result of the breaking of this ether linkage that was there. So that's just going to be an OH. The rest of these will be OCH3s. And then again, we'll have an alcohol here that can be either axial or equatorial. Yeah, okay. And so those are the two products that we would get from treating the molecule immediately above it, part 3 of B, with aqueous acid. And so that's the answer to chapter 21, problem number 90.